Have you ever wondered what powers your thoughts? Our brains are incredibly active organs, working tirelessly every second of every day. They manage our memories, emotions, movements, and every single breath we take. This constant activity demands a tremendous amount of energy. In fact, while the brain makes up only about 2% of our body weight, it consumes a staggering 20% of our total daily energy. This raises a critical question that sits at the very heart of neuroscience and nutrition. What is the best fuel to power this remarkable machine? It's a fascinating debate that often pits two main contenders against each other: carbohydrates and ketones. For decades, we have been told that carbohydrates, broken down into glucose, are the brain's preferred and primary source of fuel. This idea is deeply ingrained in our nutritional guidelines and our daily eating habits. We reach for a slice of toast in the morning or a bowl of pasta before a big exam, believing we are giving our brains the exact energy they need to perform at their best. This traditional view holds that a steady supply of glucose is essential for sharp thinking, quick recall, and stable moods. The entire system seems designed to run on this simple sugar, making it the default choice for cognitive power. However, a growing body of research is shining a spotlight on an alternative fuel source: ketones. These are special molecules that our liver produces when carbohydrate intake is very low. Proponents of ketogenic diets argue that ketones are not just a backup fuel, but a superior, cleaner-burning energy source for the brain. They suggest that running on ketones can lead to enhanced mental clarity, sustained focus, and even protection against age-related cognitive decline. This has sparked a spirited showdown in the scientific community. Is one fuel truly better than the other, or is there a more nuanced truth to be found? This essay will explore this exciting brain fuel showdown. We will dive deep into the science of how your brain uses energy. We will examine the specific advantages and disadvantages of both carbohydrates and ketones for your cognitive function, looking at what the research says. We will also translate this science into practical, real-world advice. The goal is not to declare a single winner, but to empower you with the knowledge to understand how these fuels work. By the end, you'll have a clearer picture of how to nourish your brain for optimal health and performance throughout your life. To understand the debate, we first need to look at how the brain actually gets its energy. Imagine your brain is a high-performance engine that never turns off. To keep it running, it needs a constant, reliable supply of fuel delivered through the bloodstream. The brain is protected by a highly selective barrier called the blood-brain barrier. Think of it as a very strict security guard that controls exactly what molecules can enter the brain's precious environment. Only a few substances are given an all-access pass, and our main energy sources are among them. This selective process ensures the brain receives the pure fuel it needs while being protected from potential toxins. The most common and readily available fuel is glucose. Glucose is a simple sugar that we get primarily from eating carbohydrates, foods like fruits, vegetables, grains, and legumes. When you eat a meal containing carbohydrates, your digestive system breaks them down into glucose, which then enters your bloodstream. Specialized transporters on the blood-brain barrier recognize the glucose molecules and shuttle them directly into the brain, where they can be used by brain cells or neurons to generate energy. For most people on a standard diet, glucose is the undisputed king of brain fuel, providing nearly 100% of the brain's energy needs. So, what are ketones? Ketones are an alternative fuel source that the body creates under specific circumstances. When you drastically reduce your carbohydrate intake, such as during fasting or when following a very low-carb ketogenic diet, your body's glucose stores become depleted. In response, your liver begins breaking down fats into molecules called ketone bodies. The three main types are acetoacetate, beta-hydroxybutyrate, and acetone. Just like glucose, these ketone bodies can cross the blood-brain barrier. Once inside the brain, neurons can use them to produce energy in a process that is, in some ways, even more efficient than using glucose. This ability to use two different types of fuel is a remarkable evolutionary adaptation. It ensured our ancestors could survive and maintain cognitive function during periods when food, particularly carbohydrate-rich food, was scarce. Their brains could seamlessly switch from running on glucose from a recent meal of berries and roots to running on ketones produced from stored body fat. This concept is known as metabolic flexibility, the ability of our bodies and our brains to efficiently switch between fuel sources depending on what is available. Understanding this dual fuel system is the key to unlocking the secrets of optimal brain nutrition. Glucose has long been celebrated as the brain's primary fuel for very good reasons. Its biggest advantage is speed. The process of converting carbohydrates from your diet into usable glucose for your brain is incredibly fast and efficient. When you need a quick mental boost, for example when you're cramming for an important exam or facing a complex problem at work, glucose provides an immediate source of energy. Your brain cells are perfectly equipped to metabolize glucose, allowing for rapid energy production that supports high-demand cognitive tasks like learning, reasoning, and intense concentration. This is why you might feel mentally sharper shortly after eating a balanced, carbohydrate-containing meal. Scientific research consistently supports the role of glucose in cognitive function, especially for memory. A study published in the journal Psychopharmacology demonstrated this clearly. Researchers gave participants a glucose-sweetened drink or a placebo and then tested their memory. The results showed that those who received the glucose drink had significantly better recall on memory tasks. This suggests that having an adequate supply of glucose available is crucial for the processes of memory formation and retrieval. The brain requires substantial energy to encode new information and access old memories, and glucose appears to be the most direct way to provide that power. Furthermore, glucose is essential for the synthesis of neurotransmitters. These are the chemical messengers like serotonin and dopamine that allow your brain cells to communicate with each other. They regulate everything from your mood and motivation to your ability to focus and learn. The production of many of these vital chemicals is an energy-intensive process that relies on byproducts from glucose metabolism. Therefore, a consistent supply of glucose helps ensure that your brain can maintain a healthy chemical balance, which is fundamental for stable moods and consistent cognitive performance throughout the day. Without it, communication between neurons can falter. Think of it like this: your brain is a bustling city, and glucose is the electrical grid that powers everything. It keeps the lights on in every office, powers the communication networks, and fuels the construction of new buildings. When the grid is stable and well supplied, the city functions smoothly and efficiently. This is why a diet that includes a steady source of complex carbohydrates, from foods like whole grains, vegetables, and legumes, is often recommended for supporting sustained brain power. These foods release glucose slowly, providing a reliable energy current rather than a sudden disruptive surge. While glucose is a powerful and necessary fuel, the way we consume it can create significant problems for the brain. The primary issue arises from eating simple, refined carbohydrates. Think sugary drinks, white bread, pastries, and candy. These foods cause a rapid spike in blood glucose levels. In response, your body releases a large amount of insulin to quickly move that sugar out of the bloodstream and into your cells. This can lead to a sugar crash, where your blood glucose levels fall just as quickly as they rose. For your brain, this roller coaster of high and low energy availability is incredibly disruptive. This volatility in blood sugar can directly impact your cognitive abilities and mood. During the initial sugar rush, you might feel a temporary burst of energy and alertness. However, as your blood sugar plummets during the crash, you're likely to experience brain fog, difficulty concentrating, irritability, and fatigue. It becomes much harder to focus on a task, solve problems, or regulate your emotions. Research from institutions like the University of Southern California has linked high glycemic diets, those rich in fast-releasing sugars, to poorer memory performance and reduced attention spans in both children and adults. Over the long term, a diet high in refined sugars can contribute to more serious issues, including chronic inflammation and insulin resistance. Inflammation is the body's natural response to injury, but when it becomes chronic, it can damage brain cells and disrupt neural signaling. Insulin resistance is a condition where your body's cells, including those in the brain, become less responsive to insulin. This means it becomes harder for glucose to get into the brain cells where it's needed for energy. This brain insulin resistance is now being recognized by scientists as a key factor in the development of neurodegenerative diseases, including Alzheimer's disease. Imagine trying to work in an office where the power flickers on and off unpredictably. For a few moments, the lights are blindingly bright, and then suddenly you're plunged into darkness. It would be nearly impossible to get any consistent work done. This is what a diet high in simple sugars does to your brain. It creates an unstable energy environment that undermines cognitive function and, over time, can contribute to lasting damage. This is a powerful argument for choosing complex carbohydrates over simple ones, as they provide a much more stable and sustained release of glucose, avoiding the damaging peaks and valleys. When the brain switches to using ketones as its primary fuel, something remarkable happens. Many people who adapt to a ketogenic state report a distinct sense of sustained mental clarity and focus that feels different from the energy provided by glucose. And this isn't just a subjective feeling, there is emerging science to explain it. One of the main benefits of ketones, particularly the ketone body beta-hydroxybutyrate, or BHB, is that they appear to be a more efficient and cleaner energy source. When brain cells metabolize ketones, they produce more of the energy molecule ATP per unit of oxygen compared to when they metabolize glucose. This increased energy efficiency can have profound effects on brain function. Think of it as upgrading your car's engine from standard gasoline to a high-octane racing fuel. The engine runs more smoothly and powerfully. In the brain, this enhanced energy production can support better overall cognitive performance, including improved attention and executive function. Furthermore, the process of burning ketones produces fewer reactive oxygen species, also known as free radicals. These are unstable molecules that can cause oxidative stress and damage cells. By generating less of this metabolic exhaust, ketones may help protect brain cells from damage over time. One of the most exciting areas of ketone research is in the realm of neuroprotection. Ketones don't just provide energy, they also appear to have signaling functions that can help protect the brain. For instance, BHB has been shown to inhibit a class of enzymes called histone deacetylases, or HDACs. By inhibiting HDACs, BHB can activate genes that are involved in stress resistance and longevity. A study published in the journal Science found that BHB could suppress oxidative stress and protect cells from damage. This suggests that a ketogenic state may help bolster the brain's natural defense mechanisms against aging and disease. Moreover, ketones may offer a therapeutic advantage in brains that are struggling to use glucose effectively. In conditions like mild cognitive impairment or early Alzheimer's disease, the brain's ability to metabolize glucose is often impaired. It's like having a fuel line that is partially clogged. Ketones, however, use a different entry pathway and metabolic process to fuel the brain. They can effectively bypass this clog and provide a much-needed alternative energy source. This is why ketogenic diets are being actively investigated as a potential therapy to slow cognitive decline and support brain health in aging populations, offering a vital lifeline when the primary fuel system begins to fail. Despite the promising benefits, switching the brain to run on ketones is not a simple or immediate process. The transition period, often called the keto flu, can be quite challenging and is a significant barrier for many people. When you drastically cut carbohydrates from your diet, your body has to make a major metabolic shift. It has to move from a lifetime of being a sugar burner to becoming a fat burner. During this adaptation phase, which can last from a few days to a couple of weeks, you might experience symptoms like headaches, brain fog, fatigue, irritability, and nausea. These symptoms occur because your brain is caught in a temporary energy gap. Its primary fuel, glucose, is suddenly in short supply, but the machinery for efficiently using ketones is not yet fully up and running. Your liver is learning to ramp up ketone production, and your brain cells are learning to effectively transport and metabolize them. During this limbo, your brain is essentially low on fuel, which explains the feelings of mental sluggishness and physical discomfort. It is crucial to manage this transition carefully by staying well hydrated and ensuring adequate intake of electrolytes like sodium, potassium, and magnesium, which are often lost as the body adapts. Another practical challenge of a ketogenic diet is its restrictive nature. Maintaining a state of nutritional ketosis requires keeping carbohydrate intake very low, typically under 50 grams per day. This means eliminating or severely limiting many common foods including bread, pasta, rice, potatoes, and even many fruits. For many people, this can be socially isolating and difficult to sustain long-term. It requires careful meal planning, reading food labels diligently, and often preparing most of your meals at home. This level of commitment is not always practical for everyone's lifestyle, making it a less accessible option compared to a standard balanced diet. Finally, while research into the long-term effects of a ketogenic diet is ongoing, some potential health concerns need to be considered. A poorly formulated ketogenic diet, one that is high in processed meats and unhealthy fats while lacking in fibrous vegetables, could lead to nutrient deficiencies and an unfavorable lipid profile. It is essential to focus on a well-constructed diet rich in healthy fats like those from avocados, olive oil, and nuts, along with plenty of low-carbohydrate vegetables. Consulting with a healthcare professional or a registered dietitian before making such a significant dietary change is always a wise step to ensure it is done safely and effectively. When we place carbohydrates and ketones side by side, it becomes clear that neither is universally better. Instead, their value depends entirely on the context, the task at hand, the individual's metabolism, and the desired outcome. Each fuel offers a distinct set of advantages that can be leveraged for different types of mental performance. It's not about choosing a permanent winner, but about understanding which tool to use for which job. The truly smart approach is to know when to rely on the quick, powerful energy of glucose and when to harness the steady, enduring clarity of ketones. Carbohydrates, specifically complex carbohydrates, are the superior choice for short-term, high-intensity mental tasks. If you are a student about to take a 3-hour final exam, an athlete visualizing a complex play right before a game, or a professional preparing for a critical presentation, a glucose-fueled brain is likely your best bet. Glucose provides the rapid access energy needed for intense bursts of learning, memory recall, and quick decision-making. A meal of oatmeal with berries or a sweet potato with chicken a couple of hours before the event will ensure your brain's glucose tank is full, allowing you to perform at your peak when it matters most. Ketones, on the other hand, excel in situations that demand prolonged, unwavering focus and mental endurance. For individuals engaged in long-form creative work, such as writers, artists, or programmers, a ketogenic state can be incredibly beneficial. The stable energy supply from ketones helps to eliminate the mental fog and energy slumps associated with blood sugar fluctuations. This creates a state of calm, sustained concentration that can last for many hours. If your workday involves long periods of deep work, problem-solving, or strategic thinking, running on ketones might provide a significant cognitive edge, keeping your mind sharp and clear from morning until evening. The ideal scenario, therefore, is not a strict allegiance to one fuel, but the ability to use both effectively. This metabolic flexibility allows you to tailor your nutritional strategy to your daily demands. You might choose to stay in a state of mild ketosis for your regular workday to maintain steady focus, but strategically add some healthy carbohydrates before an intense workout, or a major social event that requires a different kind of mental energy. This hybrid approach allows you to reap the benefits of both worlds, the endurance and clarity from ketones and the quick, powerful boost from glucose when you need it. Achieving metabolic flexibility, the ability to efficiently use both glucose and ketones, is the ultimate goal for optimal long-term brain health and performance. This doesn't mean you need to be on a strict ketogenic diet all the time. Rather, it's about training your body and brain to become adept at switching between fuel sources. A great way to start is by incorporating periods of intermittent fasting into your routine. By simply extending the time between your dinner and your first meal the next day, for example, a 14 or 16-hour fast, you gently deplete your glucose stores and encourage your liver to start producing a small number of ketones, nudging your brain to practice using them. When you do eat carbohydrates, prioritize quality over quantity. Ditch the refined, sugary foods that cause disruptive blood sugar spikes and crashes. Instead, choose complex carbohydrates that provide a slow, steady release of glucose. This includes foods like leafy green vegetables, berries, legumes, quinoa, and sweet potatoes. Pairing these carbohydrates with healthy fats and proteins like avocado, olive oil, nuts, seeds, fish, and eggs further slows down the absorption of sugar, creating a more stable energy supply for your brain. This simple shift can dramatically improve your daily focus and mood, preventing the dreaded mid-afternoon slump. You can also strategically time your carbohydrate intake around your activities. For most of your day, especially during periods requiring sustained focus, you might opt for lower carbohydrate meals rich in healthy fats and protein to promote mental clarity. Then you can save your larger portion of complex carbohydrates for the evening meal, which can help promote the production of serotonin and improve sleep quality. Or, as mentioned earlier, you can consume a small portion of easily digestible carbohydrates about 60 to 90 minutes before an intense workout or a mentally demanding event to provide that quick burst of glucose-fueled energy right when you need it. Finally, don't underestimate the power of exercise. Regular physical activity, especially a combination of endurance training and high-intensity interval training or HIIT, is one of the most effective ways to improve your metabolic flexibility. Exercise helps your muscles become more efficient at using both glucose and fat for fuel, and it improves your body's overall insulin sensitivity. A more insulin-sensitive body means a more insulin-sensitive brain, allowing glucose to be used more effectively. This creates a more resilient and efficient energy system, making your brain better at handling whatever fuel you provide it. The debate between carbohydrates and ketones for brain fuel is not about crowning a single champion. The true winner is the brain that has mastered the art of using both. Our journey through the science of brain energy reveals a clear and powerful conclusion. The healthiest, highest-performing brain is a metabolically flexible one. It is a brain that can gracefully switch from the fast-burning, high-octane power of glucose to the slow-burning, enduring energy of ketones, depending on the circumstances. This adaptability is a hallmark of a resilient and well-nourished cognitive system, a legacy of our evolutionary past that we can leverage for our modern lives. Relying solely on a constant influx of carbohydrates, especially the refined and simple kind, can create an unstable energy environment for the brain. This can lead to cycles of energy spikes and crashes that impair focus, mood, and memory. Over time, this pattern can contribute to inflammation and insulin resistance, setting the stage for long-term cognitive decline. On the other hand, while a ketogenic state offers profound benefits in terms of mental clarity and neuroprotection, it can be restrictive and challenging to maintain, and may not be optimal for every type of cognitive demand, especially those requiring rapid bursts of mental energy. The wisest path forward lies in embracing the strengths of both fuels. By building a diet around whole foods, prioritizing complex carbohydrates, healthy fats, and quality proteins, we provide our brain with a foundation of stable energy. By incorporating practices like intermittent fasting and strategic carbohydrate timing, we train our brain to become proficient at using ketones, unlocking their benefits for endurance and focus. This dual-fuel approach moves beyond the simplistic carbs versus ketones argument and embraces a more sophisticated, personalized strategy for brain health. It's about creating an agile metabolic engine. Ultimately, the most important advice is to become a student of your own biology. Pay close attention to how different foods and eating patterns affect your own mind. Notice how you feel after a breakfast of oatmeal versus a breakfast of eggs and avocado. Does a low-carb lunch help you power through your afternoon work? Or do you feel better with a small portion of quinoa? Your unique genetics, lifestyle, and daily demands will determine your optimal fueling strategy. By listening to your brain and making conscious nutritional choices, you can unlock its incredible potential and ensure it stays sharp, resilient, and healthy for a lifetime.